Today we're here to talk about our area formulas. So from the iPad activity the other day and probably from like junior high, we know that the area of a rectangle is base times height. So just remember, this is my base, this is my height. If you would rather say length times width, that works as well. I'm going to stick with base times height, but you are more than welcome to use length and width. Okay, so this now leads us to the area of a square. A square, remember, a square is a rectangle. So if the formula for area of a rectangle is base times height, then that has to work for the square as well. Okay, and it does work, but remember a square has all sides congruent. So if all sides are congruent, that means that the base and the height are actually the same number. So maybe you want to say base squared. Maybe you want to just call it the side length squared. Makes no difference to me. Area of a square, same as the area of a rectangle. Okay, so next up, what do we have? We have a basic right triangle, a triangle that has a right angle. So remember, a right triangle, I can draw the other half of it in and make it a rectangle. So now I have a rectangle which has got an area of base times height, but I don't want that full part. I don't want this half of it. I only want this half. So it should make sense to you that it's the area of a rectangle right here, base times height, and I'm going to divide that by 2, which gives me just the half of the rectangle I want, and that's my triangle. Okay, cleaning up our page a little bit. Next up, we have the parallelogram. So again, on the iPad activity, we got a good glimpse of this, but let's be a little bit more formal. So here's my parallelogram. I can look at this one of two ways. First of all, I can think of it as a rectangle that has been pushed over, right? If I take and I apply some force right there and push a rectangle over, I get a parallelogram. Have I changed its area by pushing it over? No, I haven't. So this leads me to the conclusion that the area of the parallelogram has to be the same as the area of a rectangle. Okay, so maybe you don't like that explanation. Let's look at this a little further. Let's take a look at what happens if I were to cut this part of the parallelogram off and relocate it over here. Okay, so I'm going to take this triangle here and I'm going to send it to the other side. Okay, and removing this and moving it over here, I've now created a full out rectangle. So if I trace that, let's see if I can get that in purple. If I trace the complete figure in purple, so now you'll see what am I looking at? I'm looking at a rectangle. What's the area of a rectangle? Okay, we know this, base times height. So if the area of a rectangle is base times height, I've given you two ways now to justify that the area of the parallelogram is also base times height. Okay, so I'm noticing a pattern here. Area of a rectangle, base times height. Area of a square, base times height. Area of a parallelogram, base times height. Area of a triangle, base times height divided by 2. Okay, if I had to guess, for the area of a trapezoid, I'm going to say base times height. The problem with the trapezoid is my upper base and my lower base are two different lengths. So how can I make the formula base times height work? The answer is I average them. I take the top base, which I'm going to call B1, okay, base 1. I'm going to take this one, I'm going to take this one, I'm going to add them up and divide by 2. We've already seen this process of adding and dividing by 2. We did this in our trapezoid unit to find the length of what we call the mid-segment or the median of the trapezoid. I prefer mid-segment. Some books, I think our book calls that the median. Okay, so when I want to find the area of the trapezoid, I'm going to use the median as my base and then my height. So the area of the trapezoid, if I write it like this, the length of the median times the height, look at the pattern. Okay, the pattern all the way down, base times height, base times height, base times height divided by 2, base times height. It's still base times height. Which base? The average of the bases. But we still now, by writing it this way, you see that pattern a little bit closer. Okay, so before we get to the kite, I've changed, instead of saying the median times the height, again, I've put it back in terms of bases. So the average of the bases times the height. Base 1 plus base 2 divided by 2. Okay, great. So moving on to the kite. Here I've drawn you a kite. Now, really, you could break apart a kite into 4 different triangles. These two triangles up top are congruent, these two triangles below are congruent. And you can find the area of each of the triangles and add them together because we know that about area. I can piece it together as the sum of its parts. Okay, so that's great, but there's got to be a formula out there, right? And there is a formula. The formula looks like this. Okay, so we've got diagonal 1. So think of this as diagonal 1 times diagonal 2. This is diagonal 2, and then you're going to divide by 2. Okay, quickly, I think it's important to point out every single formula has a multiplication sign in it. So b times h, b times h, b times h divided by 2, b times h. All of this times h. Okay, diagonal 1 times diagonal 2. Do not mix these up. In the trapezoid, you are averaging the bases, but multiplying it by the height. In the kite, it is all multiplication. Okay, last piece over here in the pink. So we've got a circle. Old news, you should know this one. Area of a circle, pi r squared. And again, notice the times sign. Pi times r squared. And there you have it. There are all your basic two-dimensional area formulas.